Water contamination, earthquakes, fears about impact on wildlife. Those are not the only problems some are linking to the technology. There's also the leaking of a dangerous greenhouse gas into the atmosphere, methane. That contention was made 2 years ago in a paper co-authored by Cornell professor Anthony Ingraffea. He says fracking leads to more methane emissions than regular oil drilling. And I asked him why.
Quite simply because shale gas development requires much more hydraulic fracturing fluid than conventional or even unconventional non-shale gas wells. Typically 50 to 100 times more fluid has to be injected. That means that what's called the flowback period, the time when this fluid flows back to the surface and has entrained in it methane, is much longer for shale gas than for non-shale gas wells, typically days or up to 2 weeks. So during that time, the methane that's coming back along with the frac fluid is either going to be vented to the atmosphere or it's going to be flared or in the best of circumstances, after some processing, is sent directly to a pipeline. So that's why we formed the opinion in our paper back in 2011 that it would be really good for us to know what industry was doing with these very, very high volumes of methane flowing back after hydraulic fracturing.
Industry group researchers not crazy about what you've said and written. Steve Everly is one of them. He's with the group called Energy in Depth. Listen to what he says about your findings, and I want to get your reaction on the other side.
The reality is that shale gas itself is an environmental solution. We've reduced local air pollution because we're using more natural gas. In the Mid-Atlantic region, you've had a reduction in toxic air pollution by about 14% thanks to increased natural gas use. Our carbon dioxide emissions are at a 20-year low because of increased natural gas use. And so this is, when you talk about shale, you're talking about an environmental solution as much as you are talking about a very significant economic solution. If you look at most of the scientific literature out here on this, the studies that have shown astronomically high leakage rates are not only suffering from some pretty significant flaws of analysis that people have pointed out, but you also see plenty of studies out there. In fact, most of the studies out there show that this is it's very low. It's below any threshold where you start having net negative greenhouse gas impacts.
Everly says your study's flawed. Others have accused you of basically junk science. So I want to give you an opportunity to respond.
Sure. Thanks for the opportunity. First of all, EID is not a scientific entity. It's a public relations entity, so I give them credit for doing good public relations by trying to belittle the science that's done by us and by others. So the allegation or the assertion that local air pollution and carbon dioxide emissions are lower because of an increased use of methane, natural gas, for electricity generation have both been shown to be incorrect. Not by us, but by leading researchers around the world. But also the idea that methane for some reason is environmentally good is just patently absurd. There's no good thing that can happen from the production or use of methane for energy production in the U.S. from the point of view of environment or climate.
But you have said that methane can be reduced. What needs to be done to solve this problem?
What needs to be done, first of all, is to figure out the magnitude of the problem. So again, EID is incorrect in stating that our landmark first paper ever on this question, published in 2011, was discredited. In fact, it inspired many people, many organizations, industry, academic, national labs to go out and make the measurements that we screamed for in that paper. And presto voila, surprise, guess what they're finding? They're finding emission rates that are higher than the ones that we estimated in our paper.
Let me bring you back to the original question, though. Can this problem be fixed?
The problem can be mitigated, reduced, absolutely. Whatever amount of leakage is currently occurring across the United States in all places, for all natural gas production and oil production, whatever the amount of leakage that's occurring across the entire life cycle can be reduced. There's no doubt about that. The question is, who's going to reduce it? And how are these reductions going to be enforced? how quickly will it take to get them in play, how much are they going to cost, and how much will that delay and that cost impede the absolutely necessary transition, not from coal to natural gas, but from all fossil fuels to renewables.
Professor Tony Ingraffea joining us from Cornell University. Thank you so much.
Thank you.